All right, guys. So today we're going to be going over getting ready for algebra. So we're just going to do some review. So the first thing we're going to start with is plan for problem solving. So when you plan for problem solving, you will use a 4-step problem solving plan. So you're going to do understand, plan, solve, and check. So let's take a look a little bit more in depth on what those are. So understand the problem. So you're going to identify what information is given, and then you need to identify what you need to find. When you plan the solution, you want to use a strategy you can use to write an equation. We're going to be choosing variables to represent one of the unspecified numbers in the problem. This is called defining the variable. Then you will solve the problem. So use the strategy that you picked in step 2 to plan the solution and solve the problem. Then in step 4, you check your solution. Check your answer in the context of the original problem. Does the answer make sense? Does it fit the information in the problem? So an example of how to use the 4-step process is we have a problem here. It says, Emily's family drove 254.6 miles. Their car used 19 gallons of gasoline. Describe the car's gas mileage. So we understand we are given the total miles driven, and we are given how much gasoline is used. And we are asked to find the gas mileage of the car. So we could write an equation. We could let G represent the car's gas mileage. So the gas mileage would equal the number of miles divided by the number of gallons used, where G equals 254.6 divided by 19. Then solve, we just simply divide, and that gives us 13.4 miles per gallon. And we can check that. We could use estimation to check that. So we could just say 260 miles, it's close to 254.6, and 20 miles per gallon is close to 19 gallons. It makes it very easy math, would be 13 miles per gallon. And since they are close and it's reasonable, then 13.4 miles per gallon would be the correct answer. So that's how you can use the 4-step process. Let's see. Let's do a little review over real numbers. So remember, when you deal with real numbers, you have values that are greater than 0 or on the right side of the number line are positive numbers, and numbers that are less than 0 or on the left side of the number line would be negative numbers. And we have natural numbers, which is 1, 2, 3, 4, 5, so forth. We have whole numbers, which are all of the natural numbers plus 0. And then we have integers, which are all of the natural numbers, the whole numbers, plus all of the negative numbers. They make up integers. And then rational numbers are numbers that can be expressed in the form of a over b or can be expressed in a fraction, as long as the bottom or the denominator is not 0. Then remember what a square root. It's one of 2 equal factors of a number. For example, 1 square root of 64, written as the square root of 64, is 8, since 8 times 8, or 8 squared, equals 64. A non-negative square root of a number is the principal square root, because remember, every square root can have 2 squares. You would have the positive and the negative, because in this example, negative 8 times negative 8 is still 64, okay? And a number that has a rational number as its square is called a perfect square. So an 8 times an 8 equals 64. That would be a perfect square. Okay? All right. A number such as the square root of 3 is the square root of a number that is not a perfect square. It cannot be expressed as a terminating or repeating decimal. So it would be approximately 1.73205 and goes on and on and on. Okay? So the numbers that cannot be expressed as terminating or repeating decimals or in the form of a fraction, then those are called irrational numbers. Irrational numbers and rational numbers together form the set of real numbers. okay? So for example, your square root of 81. Because the square root of 81 is 9, this number is a natural number. It's a whole number. It's an integer and a rational number. So a number can be categorized in multiple areas, okay, depending upon where it falls in. So you have to really look at that and be careful of that. All right, so let's take a look at some of that. So to graph a set of numbers means to draw or plot the points named by those numbers on a number line. The numbers that correspond to a point on the number line is called a coordinate of the point, and rational numbers and irrational numbers can complete the number line. So for example, if you're asked to put these numbers or these terms into order from least to greatest, you can list those all out into decimals like they did here, okay? Then you can figure out exactly where they plot on the number line, and then you can write them from least to greatest. Now, when you write them from least to greatest, write them back in the original form, not the decimal form, but the original form, okay? That's very important. Any repeating decimal can be written as a fraction. So we did this last year. This is where we take a repeating decimal and we say n equals whatever the repeating decimal is, 0.777 in this case, okay, and on and on and on. So I need to get a whole number in front of the decimal sign. So in this case, since all the sevens are repeating, I only need one 7 in front of there. I can multiply both sides of the equal sign times 10. That will move my decimal over one spot. And that would give me 10n equals 7.77 repeating. Now I've got to get rid of that repeating decimal. So I can subtract my original equation of n equals 0.777 repeating from that, and that leaves me with 9n equals 7. Now, I then can divide both sides by 9 to get rid of the 9 and get the n by itself, and that gives me a fraction of 7 over 9. Now, I could tell if I'm right or not by taking 7 divided by 9 in my calculator, and I would end up with 0.7 repeating as the answer. So I know that that repeating decimal can be written as a fraction. Okay? So that's how that would work. All right. Rational numbers with square roots that are rational numbers. So 25 is a perfect square since the square root of 25 equals 5, or 5 times 5. 144 is a perfect square of the square is a perfect square since the square root of 144 is 12. 12 times 12 gives me 144. So I could look at that as a fraction. So if I did the square root of 4 over 121, I can take the numerator and the denominator, break them down separately, and I know that 4 is a perfect square of 2. And I know that 121 is a perfect square of 11. So these represent the same thing, whether I do the square root of 4 over 121 or the square root of 2 over 11 squared. Those are the same numbers. Now, just like division and multiplication are opposites and adding and subtracting are opposites, the square root and the square are opposites. They cross each other out. So this would cross out this and leave me with just 2 over 11. Okay? All right. Estimate each square root to the nearest whole number. So this is where you have non-perfect squares and you just want to use estimation to what they are. So you don't necessarily need to use a calculator here. So if I have the square root of 15, I can take a look at what is the closest number that has a perfect square to that. Well, 9 is a perfect square of 3. And 16 is a perfect square of 4. Okay? So I can write 9 is less than 15, which is less than 16. And I take the square root of all of those, and I'm going to have 3 is less than the square root of 15, which is less than 4. Okay? So I can take a look at that, and then which one is it closer to? Is 15 closer to 16, or is 15 closer to 9? It's closer to 16. Therefore, I know that the best whole number estimate for 15 would be 4. Okay? All right, so that's how you would estimate. Let's see. Operations with integers. An integer is any number from the set, your negative numbers, your 0, and your positive numbers. You can use the number line to add integers. So if I was going to add -3 plus -4, I could start at 0. I go to the left, -3. Then I add -4. The negative sign means I move to the left. So I move 4 more units to the left, and I get -7. Okay? So that's how I can use a number line to add two negative numbers, or add negative numbers. Okay? Or positive numbers. You can also use absolute value to add integers. The absolute value of a number is its distance from 0 on the number line. So again, remember we write absolute value like 3 or -3. They both have the same absolute value of 3 because they're distance to 0. So this one is to the right of 0, this one is to the left of 0, but they're still 3 units away from 0, okay? So how I can use that is, for example, if I have the same sign, whether they're both positive or both negative, makes it very easy. You just add the numbers together. 3 plus 5 is 8. -3 plus -5 is still 8, but since they're both negative, it's a -8. Now, if the signs are different, plus or minus different signs, positive and negative, then you take the absolute value of each one and keep the sign of the larger. So I have 3 plus a -5. The absolute value of -5 is bigger than the absolute value of 3. So I would just be subtracting those, and the answer would be negative, so -2. Now in this, down below, it's -3 plus a +5. 5 is still the biggest absolute value, so the answer is going to be positive. You still subtract them, and you end up with a +2. Okay, so that's how you can use the absolute value. Now, every positive integer can be paired with a negative integer. These pairs are called opposites. A number and its opposite are additive inverses. Additive inverses can be used when you subtract integers. So for example, if you have 18 minus 23, you can simply just subtract 18 minus 23. Or you could go 18 plus a -23. Now I do just like above. I use my absolute value. I know 23 has a bigger absolute value than 18, so my answer is going to be negative. They're opposite signs, so I subtract them. I get 5. The answer is negative. Okay? So that's how you can do that. Just another little example. All right. Let's adding or subtracting rational numbers. So you can order rational numbers by writing all of the fractions as decimals. Again, just like I showed you earlier, you take all of these numbers, all of these fractions, and write them as decimals. Then you put them, whatever it's telling you, in this case, least to greatest. So you put them in order, and then your final answer, you want to have listed in the original form. Okay? That's important that it's listed in the original form. Now, to add or subtract fractions with the same denominator, or add or subtract denominators and write the sum of the difference over the numerator. So basically what they're saying here is, if your denominator is the same, then you keep the denominator and just add your numerators. So 3 plus 1 is 4. Keep my denominator of 5, 4/5. Same thing when you subtract. My denominators are both the same, so I keep that. And then I just subtract 7 minus 1, which is 6. But don't forget you have to simplify. So therefore my answer would be 3/8. Okay? So same denominator, pretty simple. Now, if I am doing with different denominators, remember I have to find the least common denominator before I can add or subtract. So in this first case, I have 1/2 plus 2/3. I have to get a common denominator. A pretty easy common denominator in this one would be 6. So I would multiply 1/2, the top and the bottom, both by 3. And on the 2/3, I multiply the top and the bottom, or the numerator and denominator, both by 2. And I get 3/6 plus 4/6. Again, same denominator now, so I can keep the denominator and just add 3 plus 7. Don't forget to simplify and get 1 and 1/6. Okay? When you subtract, it's the exact same way. You find your common denominator. So in this case, it's 24. So I multiply, and I get 9/24 minus 8/24. Since they're the same, I keep it, and I just do 9 minus 8, and I get my answer of 1 over 24. Okay? So just remember to get the denominators to be the same when you add and subtract. You can also use absolute value to add rational numbers, just like we did before. Whether it's a decimal or whatever it is, you still could take the absolute value if you have different signs. And in this case, for example, 3.1 absolute value is bigger than 2.5, so the answer is going to be positive, okay? Or in this case down here, you have a negative 3.1 plus 2.5. 3.1 is a bigger absolute value, so the answer is going to be negative. So that's how you can use absolute value to help you as that, just like we did before, okay? All right, let's see. Multiplying and dividing rational numbers. The biggest thing here is if you are multiplying or dividing with the same sign, both positive, both negative, you're going to end up with a positive answer. If you multiply or divide with different signs, one positive, one negative, you're going to end up with a negative answer. And that's all these examples are showing. So if I have a positive 7.2 times a negative 0.2, my answer is going to be negative. On B, they're both negative, so my answer has to be positive. Okay? All right. To multiply fractions, you multiply the numerator and multiply the denominators. If the numerator and denominators have common factors, you can simplify before you multiply by canceling. So what they're talking about here is I have 1/4 times 2/9. I can easily 2 goes into 2 one time, 4 goes into 2 two times, and now I just multiply across and I get 1 over 18. If I multiplied it out before simplifying, I would end up with 236, and then I have to simplify and get 1/18. So sometimes it's easier to simplify during the problem. Okay? Two numbers whose products are called multiple inverses or reciprocals. So for example, if I have 3/8, a number that would multiply together to equal 1 would be 8/3, okay? Because if I multiply those across, it would be 24 over 24, which would equal 1. So its reciprocal would be 8/3. For example, if I have 6, what is its reciprocal? Well, it would be a number that would multiply together to get 1. So remember, 6 can also be written as 6 over 1. So if I multiply it by 1 over 6, I get 6 over 6, or 1. So the reciprocal of 6 is 1/6. Okay. All right. Now let's talk about, now if we're looking at division, we're going to divide one fraction by another fraction. You're actually multiplying the dividend by the reciprocal of the divisor. So if I have 1/3 divided by 1/2, I'm going to use the reciprocal of 1/2, which would be 2 over 1, and then multiply instead of divide. So 1/3 divided by 1/2 would be 2/3. Okay, so you're just flipping or reciprocal and changing it to multiplication. All right, the percent proportion. A percent is a ratio that compares a number to 100. To write the percent as a fraction, express the ratio as a fraction with the denominator of 100. Fractions should be expressed in simplest form. So all you're doing is if you have a percent, you put it over 100. So 79% would be 79 over 100. 107% would be 107 over 100. But then you simplify, and it would be 1 and 7 over 100. Even if your percent is a decimal, it would be 0.5 over 100. Now remember, we want to get rid of that decimal, so all we have to do is multiply by 10. And when we multiply times 10 on the top, we would have to multiply by 10 on the bottom, and that gets me 5 over 1,000, and then just simplify down to 1 over 200. Pretty easy. All right. Now, in percent proportion, the proportion of a part of something to the whole or the base is equal to the percent written as a fraction. So for example, I have A over B, or part over the whole, equals the percent over 100, okay? So if I have 40% of 30 is what number? I just plug into that formula what I know. I know 40% is my P. I know 30% is my whole. I'm looking for my part. So then all I have to do is cross multiply, and I get 100A equals 30 times 40. And that would be 100A equals 1200 divided by 100, and A equals 12, or 40% of 30 is 12, okay? You can also use percent proportion to find percent of the base. So in this case, it says Kelsey took a survey of students in her lunch period. 42 out of the 70 students Kelsey surveyed said their family had a pet. What percent of the students had a pet? So we know that the part is 42. We know that the whole is 70 students, but we don't know what the percent is. So we just plug in what we know, we cross multiply, we get 4,200 equals 70p, divide both by 70, and 60, or 60% of the students had pets. Okay, so just plug in what you know and solve for what you don't know. All right. Let's see, what do we got? Now we're talking about perimeter. Remember, perimeter is the distance around a figure. Perimeter is measured in linear units. So we could actually create, instead of adding every side, we could create formulas. So for perimeter of a rectangle would be 2 times L, or length, plus W, or width, or we could say 2L plus 2W. On a parallelogram, we could say 2 times sides A plus B, or 2A plus 2B. On a square, we could say 4 times S, or 4 times a side. And a triangle, you just have to add all three together, side A, side B, and side C. All right, so an example of that would be find the perimeter of each figure, a rectangle with the length of 5 inches and the width of 1 inch. So we just plug in what we know. We know the length is 5. We know that the width is 1. So 5 plus 1 is 6. 6 times 2 is 12. The perimeter is 12 inches. That's all there is to finding perimeter. All right, circle. Remember the parts of the circle. You have the diameter, which is from one edge to the other edge. You have the radius, which is from the center to the edge. And you have, of course, the center. And then you have the circumference, which is the distance around the outside of the circle. That was a horrible circle. Around the outside of the circle. The formula of the circumference of a circle is C equals pi times D, or diameter. If you don't have the diameter and you have the radius, you could use C equals 2 times pi times R, or radius. Okay, so it depends on what you have. So let's take a look. If I have the radius equals 4 feet, I just plug 4 in for the R, and it would be 2 times pi times 4, or 8 pi. And if I wanted to multiply that out in my calculator, I just put 8 times pi, and it would be 25.13, so forth. And then I would just round that to the 10th, because that's what it said, 25.1 feet. Now, if they gave me diameter, I could use C equals pi times D. And in B, they do give me the diameter. So it would just be 15 times pi, or approximately 47.1. So it just depends on what they give you on what you would use. All right, let's look at area. Area is the number of square units needed to cover a surface. Area is measured in square units. So, for example, a rectangle, area equals length times width. Parallelogram, area equals base times height. A square is the side squared. And triangle is a half times base times height. Okay? So we could find the area of a figure. If a rectangle with a length of 7 yards and the width of 1 yard, plug in what we know. It's just length times width. So 7 times 1, or the answer would be 7 square yards. don't forget to put the square yards. And remember, I could write that also like that. Okay? All right. Now let's look at area of a circle. Now remember, the area of a circle is area equals pi times r, or radius, squared. Now, the key to this is remember what they give you. Do they give you the radius or the diameter? If you get the diameter, you have to divide by 2 to get the radius. So find the area of a circle to the nearest tenth. If they give me the radius of 3, then I plug 3 in for the radius, and it would be pi times 3 squared. 3 squared is 9, because remember this goes together, would be 9. 9 pi would be approximately 28.3 square centimeters. Now, this one they give me 21 meters as a diameter. I need radius. So I would have to take 21 divided by 2 and give me 10.5. So now that equals my radius. So then it would be pi times 10.5 squared, and 10.5 squared is 110.25 times pi, or approximately 346.4 square meters. Okay? So again, if you get a diameter when you're looking for area of a circle, you have to figure out what the radius is. All right, volume. Volume is the measure of space occupied by a solid. Volume is measured in cubic units. To find the volume of a rectangular prism, you would multiply the length times the width times the height. So for example, if we're looking for this prism, which has the length of 4 feet, width of 2 feet, and height of 3 feet, we plug in what we know, 4 times 2 times 3, which is 24 cubic feet. And remember, I could write that as 24 feet cubed. Okay? So that's how I could do that. Now, the volume of a cylinder is a little bit different. The formula is V, or volume, equals pi r squared times the height. So you're looking for the area of the circle, or the base, and multiplying it times the height. Okay? So in this case, they're giving us the radius of 3 and the height of 6. We just plug it in. And remember, the square root goes with the number. So it would be 9, or pi times 9 times 6, or 54 times pi, which would be approximately 169.6. And remember, that's cubed, so you would want to label that as cubed inches. All right? Now, don't forget, too, if they give you the whole diameter, and let's say it was 6, I would have to divide that by 2 to get my radius of 3. So in this case, they gave you the radius, so you didn't have to do anything. But if they give you the diameter, you have to find the radius first. All right. Let's see here. Last thing, surface area. Surface area is the sum of the areas of all the surfaces or faces of a solid. Surface area is measured in square units. So it's all of the surface area on every side, okay? On a cylinder, it would be the both bases all the way around, okay? So on a prism, it would be 2 times length times width, plus 2 times length times width, plus 2 times width times height. Oh, I'm sorry. Messed that up, didn't I? 2 times length times width, and then 2 times length times height, and 2 times width times height. All right. And then on a cylinder, it would be 2 times pi times radius times height, plus 2 times pi times radius squared. And that would cover all of the areas on the outside. So find the surface area of each solid round to the nearest tenth if necessary. So we have this rectangular prism with a length of 3 meters, the width of 1 meter, and the height of 5 meters. So once you identify what you have, so this is my L, this is my W, and this is my H, then I just plug it into the formula, each number where they go, multiply, remember your order of operations, multiply first, then I add them all together, and I would get 46 square meters, or I could write it as 46 meters squared. Okay? Well, that's the review for this lesson. If you have any questions, just let me know. Have a great day.